vessel feeding through it, or it has been the 4 to 5 days past the feeding time. Like I said, those are the stink bug punctures. Okay. Another pest I'm going to mention, along with a couple more, are the pecan weevils and their damage. You can see here, this is the male and the female pecan weevil. The female pecan weevil is actually the one that causes the majority of the damage to the pecans, mostly all of it. It's hard to see, but this is a small spot where the female takes that long snout and they'll actually stick it into the pecan, and they will walk in circles and use their snout as a drill and drill all the way down through the shuck and into the kernel. There's small little dots going around that circle right there. That's actually the little foot marks where they just grabbed a hold and walked in a circle to drill in. Once they drill in, they actually lay an egg in that hole. The egg then hatches. The larvae will crawl down into the pecan and it will feed. And once it's mature, it will come out through a hole right here in the inside of the pecan. As I'm sure most of you know, it's just gone. They just keep going. And then that's the oviposition site, and that's the emergence hole. A couple other pests I'll be talking about right here is the hickory shuckworm and the pecan nut case bear. Both these are moths, and they will actually cause the pecans to stick to the tree so they don't drop, and it will also cause it so the shuck won't open. So, as you can see, the shuckworm is to the left, and the pecan nut case bear is to the right. That brings us to objective 2 for this project. That will be done this summer. We're going to be looking at how do pecan damage and pecan number of stink bugs of each stink bug species compare among pyramid traps, UV traps, and pyrethroid sprays pecan trees. Well, I already mentioned how we're going to determine damage and how the yellow stink bug traps work, so now I'll go into the UV blacklight trap. This is just a standard UV blacklight trap that we're going to mount about 2 meters off the ground so that the stink bugs will be attracted from the canopy and the ground cover both. We're going to place these UV traps at 5 farm sites. So they'll be turned on one night every 2 weeks. Just because if we turn them on more than that, they're very effective and will catch everything. The trap catches will then be bagged, sorted, and the species will be identified. That brings us to the absolute count. The way that we're going to do the absolute count is we're going to use an insecticide sprayer to apply a knockdown spray of pyrethroid to determine the absolute numbers of the stink bugs present in the pecan trees, so we can relate the other traps to what's actually in the trees to see how effective they are. The image you can see there is a backpack sprayer. That's actually a still 450, and that's just them spraying the tree to show how it's done. That brings us to the objective 3. For objective 3, we're looking at a cage study that will determine or describe nut damage by each stink bug species and answer the question, what type of pecan nut damage does each species of sucking bug cause, and when is it caused? So we're determining this by doing a screen cage study, much like it was done in pistachios by Donn et al. The cage can be seen from Dann's study, and that image is on a pistachio tree. It's placing the cage around the terminal end where the pistachios would be. We will be using that method on pecans. Since pecans, the nutlets actually have to form before we can cage them. So we'll be putting these cages on the nut over the terminal ends of the branches in June. This experiment will be ran from July through September, and the cages will be looked at bi-weekly. So for each nut growth stage, 2 stink bugs of one species will be placed inside of each one of the cages and be allowed to feed for 7 days. The bi-weekly changes in the nut damage in the cage will be photographed and categorized. So we categorize as there's old damage, new damage, no damage, or the pecans actually dropped. At harvest, we will remove the pecans and we'll look at them to compare the external damage to the internal damage on the pecans. That brings me to the results of the objective 1 that we did from last year. First off, I'll explain this graph real quick. On the left vertical axis, you can see the mean number of stink bugs in each pyramid trap. Along the bottom is just time, and over to the side, this is all the different farm sites that the experiments were running. So, trap counts appear differently across all farms groups, except for the 2 sites right here that are both in Blackwell. They are similar. I also want to point out again the 2 generations of stink bugs that I mentioned multiple times. They can also be seen right here. This is generation 1. That is the 2nd generation of stink bugs. Also, I'd like to mention that damage from stink bugs early on doesn't contribute to the later damage count, because if they're fed on before the water stage, most likely the tree will abort the pecans, so they'll fall off before they ever become mature. Okay. So, a couple of the sites that we looked at. First, there's Blackwell, Arkansas. This is what we call Site 2. The surrounding crops around this, this is all oriented, so north is up. This is rice, soybean. This is actually a levee right here, and this is the Arkansas River. Right up here, that is a cow pasture. So keeping all those sides in mind, we then look at where the stink bugs densities are the greatest. As we can see here, the mean number of stink bugs were significantly greater in the center than any other trap locations of the 5 different sample days. These asterisks signify that it's significantly different. So you can see the center of the pecan grove has more stink bugs present significantly than any of the sides that border the rice and the soybean at the site. That brings us to site 1 in Blackwell, Arkansas. Again, well, since we all know last year was kind of a off year, they attempted to plant soybeans on this side and this side, but the crops failed, so it was more of a fallow field. Right up here, this is fallow, just a grassy field, fairly unkept, and this is another pecan grove. Down to the south, this is actually the levee again that they allowed to grow up with grass. And on the other side of the levee right down here, this is more pecan trees. So again, keeping that in mind, you can see here the mean number of stink bugs was significantly greater in the center and the south side than the west side on only one sample day. So this is the center and the south side, and they're significantly greater only on that one day. And the center again is just in the center of the pecan trees. And the south side was the grassy levee and along the river. So there was more of a refuge formula. Then Humphrey, Arkansas, here's the 3rd site that we looked at. Here, the north side, these are all just woods, just a forest. This is a lake, this is soybean, and this is just a maintained, kept lawn. So he's very particular, he just kept it mowed. Here we can see the mean number of stink bugs were significantly greater on the north side than any other location, only on one sample day. You can see that orange, where it's numerically higher, it's actually significantly greater right here on that one day. And again, the north side is the side that had the forest right there and all the brush cover, and also the lake. So that brings me to the percentage of stink bug, pecan beetle, and pecan nut case bearer hickory shuckworm damage from the 2012 experiment. In this table here, these are the different sites. Sorry. Those are the different sites that the experiment was run in. SB stands for stink bug, PW stands for pecan beetle, IL stands for internal LEPS. That actually includes both the pecan nut case bearer and the hickory shuckworm. We just lumped them together. As you can see, Blackwell, Arkansas, the sites 1 and 2 had very low damage, mostly for all of the pests, while Mayflower had fairly low damage for stink bugs and very low damage for common eagle and turtle leaps. The Humphrey site, it had high damage for mostly all of the pests. The stink bugs had a 28.6% damage at the very end of the season. The pecan weevils had 29.3% damage, and the internal leaps had up to 10% damage. Then we can have one more site in Garland City that's being looked at here. It had fairly low stink bug damage, and the internal leaps were actually very high there. So the idea was the more stink bugs that are present in greater density, the more damage that would occur. But that only holds true in Humphrey site. It has the most damage, and it has the insects are increasing there. But at the other sites, you can see that it doesn't relate that way. We're actually going to do this study again this year and see if we can get more information on what's happening here. Are there any questions? Yes.
The management of your turf, is the organization the same or the Humphreys?
No. Actually, the majority of them are grown and cut for hay, while the site Humphrey, he actually maintains it and mows it like a lawn. He keeps it fairly well cut.